Okay, Assalamualaikum guys. We go to the topic which is separable partial differential equation. Okay, what is PDE? So in PDE, it has two or more independent variable. Unlike the ODE, it has one independent variable. So, okay, we can write in the PDE in an equation for example, x square, denote the dependent variable. Okay. Meanwhile, the sub xx, okay, refer to the independent. So when we write in Leibniz notation, it will be d over dx, okay, du over dx. Similar like this second example here, u is your dependent, okay, x and y is your independent variable. Okay, similar like ODE, PDE can be classified into homogeneous and non-homogeneous. So basically, when the PDE equals to 0, okay, so means that the PDE is homogeneous equation. Meanwhile, when it is equal to some function of x and y, so the PDE is considered as non-homogeneous PDE. So basically, second order PDE can be classified into hyperbolic, parabolic and elliptic. Is b square minus 4ac greater than 0, hyperbolic. Parabolic if it is equal to 0, and elliptic if it is less than 0. So our concern here is the coefficient in front of delta u over delta x square. Okay, for A, b is a coefficient that multiply with delta u over delta x delta y square. Okay. And C is the coefficient that multiply with delta u over delta y square. Meanwhile, the other coefficient can be ignored in order to classify the PDE. So we go to the classification of PDE. So we need to identify A, B, and C. So for example here, A equals to 3. Okay, we taken from delta u over delta x square. So B, which come from delta u, okay, delta u over delta x, delta y, we don't have that term, means that it's equal to 0, coefficient is 0, and C, which comes from delta u over delta y square, is also 0 for this example. So when we substitute into b square minus 4ac, what we get here is 0 minus 4 multiplied with 3 multiplied with 0, so we get 0. So the first equation is parabolic. Okay. For the second example, okay, I need to bring to the left hand side, okay, all the terms. So it will be delta u over delta x square minus delta u over delta y square. So when I substitute A equals to 1, B is 0, we don't have delta u over delta x delta y square, and C equals to, we taken from delta u over delta y square, so negative 1. So when I substitute b square minus 4ac, I will get here b square is 0 minus 4 multiplied with 1 multiplied with negative 1, so we get 4. So 4 greater than 0 means that this equation is hyperbolic. So the third equation here, A is 1, B 0, and C equals to what? 1. So when we substitute b square minus 4ac, we get here, okay, what we get is 0 minus 4 multiplied with 1 multiplied with 1, so we get negative 4. Therefore, this equation is elliptic. Okay, before I show you how to solve PDE using separation of variable, where we have to find the product between two functions. In our case, let's say we have x and y independent variable, means that we have to find the product between function of x and function of y. I will show you how to reduce the linear PDE into the linear ODE, because in order to solve using this method, you have to reduce the equation into the linear ODE. So for the first example here, we have delta u over delta x square. Okay, so we know that our equation have a variable x and y. So look at the denominator here. okay, second order which belong to x, so x double prime. Okay, that's how we write the linear ODE. For the second example, we know that we have x and y variable. Look at the order here, belongs to y, so y double prime. Okay, sy double prime. For the third, okay, example, also we have x and y variable. Okay, and the first order here belongs to x, so x prime y. For the fourth, okay, we have x and y variable, independent variable, so y, first order of y is belongs to y, so sy prime. So that's how we reduce to the linear ODE.